So, ladies and gentlemen, welcome on International Workshop on Urban Heat Island and Noise, organized in the frame of European LIFE project Heatland, in cooperation with our partners from Europe and United States. So, good late afternoon, Europe, and good morning to Arizona and LA. My name is Vladimir Gumilar. I'm a cluster manager of the construction cluster of Slovenia, a non-Spanish partner of the mentioned LIFE project. I will just welcome you and try to coordinate the event. Today, the focus is on noise. So how loud the noise is? Are we just accepted the fact that noise is part of our life and we don't listen and also don't hear it? It doesn't need to be so, and it shouldn't. Noise is an underestimated threat that can cause a number of short and long-term health problems, such as, for example, sleep disturbance, cardiovascular effects, poor work and school performance, and much more. And we are affected. Yes, we are. According to European Union, there are 40% of the population in EU countries exposed to road traffic noise at levels exceeding 55 decibels. 20% is exposed to levels exceeding 65 decibels during the daytime, and more than 30 is exposed to levels exceeding 55 decibels at night. How loud is too loud? The World Health Organization guidelines for community noise recommending less than 30 80 decibels. So reduction for 3 decibels is 10%, but also more in terms of impact. In a couple of minutes, you will see why I mentioned 3 decibels. So how can we deal with noise? And also heatland, which is the second subject of today's event. On the agenda, we have 3 presentations, and case studies from Europe and 2 from United States of America. Not to lose time with the detailed presentation of the agenda, I invite all speakers to present themselves at the beginning of their presentations, and to have a smooth webinar, please mute your microphones and post questions in the chat to make it also dynamic and interactive. So I would like to invite firstly our colleague Francisco Miguel Moral to start the presentation. Go ahead, Miguel. Francisco. Just a second, stop sharing, stop share. Yeah.
I think now you see my presentation, right?
Okay.
Okay. Well, hello, everyone. Thank you for virtually coming today with us. My name is Francisco Moral, and I am the head of the Energy and Insulation area at the Construction Technology Center, CTCON, which is located in Región de Murcia, in the southeast of Spain. Oh, sorry. No. Okay, it is well known nowadays that temperature is getting higher and higher due to many facts, such as anthropogenic heat, dark surfaces, or heat from machines, among others. Temperature in cities is up to 4 degrees higher in the city center than the outskirts. That is called the urban heat island effect, and we can solve this problem through several ways. For example, increases our shadows in our cities with green roofs, with the help of cool roofs, or in our case, with cool pavement. Almost 40% of the surfaces in the cities correspond to traditional pavements. These pavements absorbs 90% of the incident solar energy, and their surface reaches close to 70 degrees. Inspired by our colleagues from the USA, that they are here today, in previous researches, CHM construction company and CTCON developed together a new pavement whose thermal performance was much better. This is the new cool pavement, as it is known. And as you can see in the graph, the cool pavement, green line, absorbs less energy than the traditional one. And this is how the idea of the LIFE HEATLAND project came up, to demonstrate in real conditions its advantages with the funding of the European Union. And the partners started working together. The partners are the Construction Technology Center as the coordinator, CHM Construction Company, Murcia Municipality, the Regional Federation of Entrepreneurs of Murcia, and the Construction Cluster of Slovenia. What were our goals? Well, mitigate the urban heat island effect by reducing the surface and environmental temperature with this new technology, contribute to a better quality of life and people's well-being, achieve energy savings in the urban environment because of the savings in the public lighting system, reduce air pollution, and finally develop a tool to assess the impact of the implementation of the cool pavement in any city, that I will tell you something here later. Now we are going to watch a video we have prepared to show our implementation works.
LIFE HEATLAND project, innovative pavement for mitigation of urban heat island effect. Project co-founded by the LIFE program of the European Union. After a year monitoring parameters such as surface temperature or solar radiation, LIFE HEATLAND project reached the most important milestone in February 2020, the implementation of reflective pavement. This innovative cool pavement has been manufactured in the facilities of the construction company CHM, which has redesigned the plant to adapt the characteristics of the new mixture. This mixture does not use the traditional black bitumen derived from petroleum, but a colorless synthetic binder which has been obtained from a mixture of high molecular weight organic components. The process followed to carry out the implementation is as follows: miling the existing pavement, adding emulsion to ensure intercoat adhesion, implementation of the mixture, compaction of the mixture, painting to replace the road markings, quality control tests such as slip resistant tests and thermography were carried out. Works have been carried out on an area of 24,000 square meters, comprising a total of 7 streets, 6 paved with the innovative cool asphalt, and 1 paved with a traditional one in order to be able to compare measured data. At the moment, the visual results after the works is spectacular. The 2 aspects that most attract their attention are the reduction of noise and the good night lighting.
Yes. Okay. Yes. And you can see here our implementation area, which was also in the video. And we have located 4 measurement towers that take data every 15 minutes of 25 parameters, such as surface temperature, ambient temperature, humidity, carbon dioxide, noise at 4 meters, for example. And we have generated 6.5 million data until now, from the beginning until now. And here you can see a couple of pictures of how this new cool pavement looked like at the beginning. This is from the rooftop of a building in front of the main road. and a comparison between both of them. But however, I have to tell you something, because the beige stone that we had initially has evolved over time to a white stone that, due to air pollution and the particles present in the environment, results in a gray stone. You know, however hard we try, it is impossible to eliminate this phenomenon. Long story short, this happens in the same way to the traditional pavement, but nobody notices because it's black. In spite of this, the energy and light properties are hardly affected, as I'm going to tell you in the following slides. And also, as you can see in the day 120, the passage of vehicles and the rain contribute to clean the pavement. Especially when we have strong rains, this pavement is cleared. We have also developed a business intelligence tool because we had 6.5 million data. It is impossible to do it with Excel because Excel was overwhelmed with such a huge quantity of data. So we developed a business intelligence tool to analyze our data. Now let's talk about our results. First, luminance has been increased by 150% initially, and you can see the picture. And now this value is 100%. The increase is 100%. And you can see the two pictures from below. Is how it looks like nowadays in the night. Solar reflectance is 170% higher, and you can see the graph. It is a stabilized value. What about surface temperature? It has been increased, the general performance decrease, sorry, between 7 and 11 degrees. And here you can see a thermography for May the 6th, 2020, in the worst conditions, because it is a thermography of the interface between the traditional pavement on the right side and the cool pavement on the left side. And the difference was 6 degrees. If we see another thermography from those straight but not too close, yeah, you know, 7 degrees the mean difference between both of them, and 10 degrees the maximum difference. So the general performance is a decrease of temperature, surface temperature, between 7 and 11 degrees, as I have said, and we have maximum peaks of 15 degrees. And here, as I have mentioned, the gray stone of this asphalt, you can see the difference between the dark and clean side of the cool pavement, and the difference, the huge difference between the traditional and the clean cool pavement. In order to spread and replicate our technology, as I have mentioned in the objectives of our projects, we have developed an app which contains the mathematical model developed to describe all these physical phenomena. And we have validated this model and this app with the data collected by our 4 measurement towers, and also with meteorological data that doesn't belong to our project, from the outside of our project area. And finally, as you can see in this graph, noise has been decreased by 3 dBAs in the end. Okay, and it's very clear when we implementate the pavement, we have a reduction, and after the strict lockdown that we suffered, now these values have recovered. So we have 3 dBAs of decrease in the noise, and also it is the same value nowadays. This is a reduction of 3 dBAs. And you can hear these recordings for noise. This is the cool pavement and the traditional one. Okay, maybe if you don't have headphones right now, you can't notice the difference, but here it is the graph of the wave. Okay. And yes, this is a summary of our results. This pavement has not a relevant impact on pollutants and the same values that I have mentioned before. And finally, I can tell you that we have reached an agreement with Barcelona Municipality in order to replicate our project there. And we will pave with our cool pavement by the end of this month, the 27 and 28 of November. And it is a huge success of our project, and we are very happy. And that's all. I have finished.
Thank you, Fran. Are there any questions? Fast ones, short ones for Francisco. If not, we can go on with the fight against the noise and heat in the city, life, cool, and low noise impact project. Giulia, Custodi, Mailys, Chanial from Paris. You can share the screen and start with the presentation.
Sorry, yes, Vladimir, we have a question from the chat from Greg Spots.
Yeah, okay.
Yes, the cost difference is the double. We have 100%. The double of the cost of the cool pavement is 100% up to the traditional nowadays because of the synthetic binder.
There is another one, has a study of the climatic impact of the cool pavement on the air temperature and a heat stress been made?
Not about the heat stress. We have developed also a socioeconomic study of the impact of our project, and people in the streets, the neighbors of this of the implementation area notices the difference in the surface temperature, ambient temperature.
Okay, you answered my question already. Yes, I think this is really important because we talk about indoor air quality, but also outdoor air, heat, noise quality nowadays. This is very important. There's another question. What is the name of the model that you present, please?
I think you mean the mathematical model.
Yes.
I don't remember the name now.
I think you can ask the university to provide more on that information. Okay, thank you. Not to skip any question anymore. Is there any other thing to discuss? Oh, well, the issue with the freezing. Have you finished that study or done something in this regard? Because this is important for Slovenia.
I can answer your question right now. Yes, I have to talk to my colleagues here from the CTCON, because I think I remember that it is not a problem.
It's not a problem. Perfect.
Yeah.
That's good news. Well, another one. That's good.
Yes. It is necessary to adapt the plant because it is necessary only one line, one production line exclusively for this cool pavement. Because if you use the same line for the traditional, you are going to you will have a darkening effect in the pavement. It is necessary to have all the machine and the production line clean. And it is necessary to have one specific line in your plants to produce this asphalt or any other colored asphalt. Confirm.
Okay, thank you very much for these questions. I think we can jump to some of them if they will occur later on, no problem. So let's keep the agenda on time. And I would like to invite, I think, two ladies from Paris to present their project.
Giulia, if you are speaking, we can't hear you.
Hear you, yes.
Yes.
And don't see you either.
Okay, Giulia, we'll wait.
Can you hear me?
Yes, but please speak a little bit louder.
Okay.
Yes, we hear you, but on low volume.
No, not at all.
No, it's better.
Much better.
Now it's normal.
Oh, okay. Sorry. Earlier it was very good, and now that we have presentation with some problems. So I will share the PowerPoint. If you are agree, we decided to split the presentation in two. I will present the general information of the project, and Mailys Chanial will present something more specific on the thermal and microclimatic aspects of our project. So I am the project manager, Giulia Custodi, of the LIFE Cool and Low Noise Asphalt, and The project started in 2017 and it will end in 2023. We are starting to make measurements and analysis of acoustic and thermal and microclimatic aspects in 2019. So now we are in our third year of monitoring of the results. For some general information, we are deploying 3 innovative bituminous road surfacing formulas that aim to improve the phonic and thermal property of more traditional asphalt mixes to reduce noise pollution and the effect of global warming at the same time. In fact, we are the first European project to research asphalt solution that simultaneously have these better noise and heat protection performances. And there is another very important objective, that is an economic performance. We are expecting to have overheads that of the final production that are less than 10% compared to a conventional pavements. And to achieve this goal, we chose to have innovative materials that are produced from existing manufacturing technologies and that are available in today's market. So we are also starting to develop this formula on other streets of Paris, and we are looking for reproduce and replicate in the national and European territory. The city of Paris is leading the project and is in partnership with the companies Colas and Eurovia, and the Center of Technical Assessment of the Sound Environment and of Île-de-France, Bourg-et-Paris, and with the Université de Paris, le LIED laboratory, with PhD theses that are co-financed by City of Paris and Université de Paris. And I would show you a short video. Can you see it? Can you see it?
No, we cannot see it.
I will share another. Yes, this maybe. Now can you see?
Yeah.
Yes. So it was to share with you the general information, and now I would like to go on the materials implementation. So for the three formulas have been designed by Colas and Eurovia. Two of these three formulas have been designed by Colas, and the smartphone and Babyphone Plus. For smartphone, it was select all these three materials are selected by the already existing materials, and for the smartphone, it was selected because it offers a very homogeneous surface and also reduces the noise created by tires in contact with the road. It features a lower proportion of aggregates, reducing the size of aggregates, enhances the mixed sound dampening qualities. The aim is to reduce vehicle rolling noise and improve sound absorption by 20%. And the smartphone is designed also to retain water. For Babyphone Plus, the feature aggregates in pale colors from the French town of Montebourg, and it was selected because it is most effective in terms of mechanical resistance and noise reduction through its entire thickness. This solution has been specially designed for conurbations, and it is engineered to withstand the aggression generated by urban traffic, like parking, intersection, mechanical caning, etc. To help combat urban heat islands, it retains water and contains aggregates in very pale colors. And for the third formula, it is a porous urban mastic asphalt named Puma by Eurovia. And it has been studied with the clear aggregates, and this formula was chosen because it presents the best compromise between thermal, mechanical, and financial aspects. The porous aggregate retain is ultimately porcelain, which has real economic advantage. And the disadvantage of which, in terms of clarity, has been compensated by the addition of a calcined ground silica of 14% of ground seal. It offers an innovative sound and thermal performance while maintaining important mechanical and durability characteristics. So these three formulas has been tested by the companies during 2018, and then they have been installed in late 2018. And today we are monitoring that since 2019 in these three pilot sites. They are tested so in for 400 meters long in each site. These three sites have been chosen by their characteristics. They are heavily exposed to road noise. That is Rue Frémicourt, Rue Lecourbe, Rue de Courcelles in the city. We can say that is the center of Paris. Each site is equipped with various sensors and is coated half with an experimental formula, and for the other half with a Parisian standard pavement, in order to compare this solution in a real time. There are 14 permanent measuring stations that have been installed to evaluate the acoustic and thermal performances. And for the what is concerned noise aspects, The goal is to reduce the noise pollution generated by road traffic on urban road, thanks to these new pavements, by reducing the noise emitted by the contact of vehicles, vehicle tires, sorry, with the asphalt. That it's the rolling noise of the tires. To do that, we have two types of measurements. To survey that, we can say. We have CPX measurements, that is a digital audio recordings on the roadside and continuous proximity. That consists of measuring the noise emitted near a rolling test tire, complete the acoustic evaluation device. Like you can see, this is an electric car with the microphone and the equipment at near the tire. The measurements are made at night every year, and for the second type of analysis, we have noise facade buildings measurements, and for now we can say that for the facade noise measurements, we have the results of 2019 and 2020, and for CPX we have also 2021. In general, we can say I am not going deeply into the description of our analysis method, but I can say that the project objectives in terms of reducing rolling noise compared to standard solution are achieved for two of the three formulas, and for the Puma, that is the last one, we cannot say yet, because we had working site issue, and the reference was not representative of reality. However, we can say that we have a significant reduction in noise levels associated with tire road contact noise during the night period, especially, and we have also for CPX, we have results for 2021 also, and we can see that in 2019 it was a very good performance, and now we still have good performances for the three roads. For Babyphone, Asthmaphone, and for Puma 2, even if what the problem was that the reference seems to be better than the innovative one, but we are. How can I say it because some working site problems that we have this aberration, and so I can show you another little that's it. We have chosen to make this effort to communicate on this project on our story. And last but not least important thing I have to say to you before letting Mailys talk about the microclimatic and thermal aspects, we choose to make some information moments with the inhabitants in September and October 2021, and we made some questions in order to understand the feelings and if the benefits of these innovative asphalt mixes are distinguished, are felt by human here, and we can say that we have noticed a good response from the inhabitants that said that they noted a reduction of road noise and consider also important to above all implement this experiment in other streets of Paris, because our experimental sites are really punctual. Thank you very much. I can pass to Mailys Chanial for the microclimatic. Yes.
Can I jump in with one short question? Have you
yes.
tried to get some feedback from experts for health? What does it mean 2 to 3 decibels of reduction of noise? You know, not from just interviews with people, but you know, from
yes.
Let's say physical science.
Less 3 decibel. It is in like to reduce of an half the noise of a street.
Mm-hmm.
Yeah. Yes. In terms of implementation and reducing noise, it's a very good objective. Yes, it's a very good result.
Yeah, I know, but what I would, you know, suggest is that for both projects, somehow, you know, how less people injured or having some kind of issues with this kind of reduction can be expected, you know, in a number of figures, which can be then promoted to the municipalities to implement this kind of payments in other areas of the city. So this, you know, this kind of numbers might help a lot. So just a suggestion.
I would like to. I'm not sure to understand the suggestion, and I would like to. I would like to understand better. What do you?
Giulia.
Yes.
La question c'est est-ce qu'on a étudié l'impact de moins 3 décibels sur la santé? C'est sa question,
okay.
Je pense.
Okay.
I don't speak French, so I
No, but do you want to know if we studied the impact of this reduction on the health?
Yes.
Yeah.
My thinking goes in the direction that, you know, some kind of actual figures on improvement of health situation, less some kind of diseases or some kind of situations leading to needed treatments in hospitals or that kind of stuff, or anything in figures would even more improve the impact of the project.
Yeah, but we had these studies, and I think it is important when we are talk to Parisians habitants to communicate on this, because they now that the project has already 3 years, people have started not to remember the difference from before and now, for example. So yes, it is important to remember it.
Yeah. Okay. Thank you. So go on, please.
Hello, can you see my screen?
Yes, we can.
Yes.
Okay. So, hello everyone. I'm Mailys Chanial. I'm a second year's PhD student at the lead lab from University of Paris and from Paris City Hall. And so I work on the analysis of the thermal and microclimatic behavior of the innovative pavement for the Life School and Learners Asphalt project. So as Giulia just told you, the aim of this project is to improve the acoustic and thermal performance. So I'm just going to talk about the macroclimatic and thermal performance. And so to increase those performance, they work on the water retention capacity to optimize the impact of watering during heat waves, because since 2013, the Paris City Hall experiment watering pavement. So they start on another street, and now it's continue with those 3 streets equipped with innovative pavement. They also worked with to increase the reflectivity of the aggregate. So just on the bottom, you have a picture of one of our asphalt installed Rue Le Courbe. On your right, you have a picture of a measuring instrument. On the right, this is the acoustic measuring instrument, and on the left, you have the weather station. So each of our streets are split in a different area. We have the control, reference, and innovative area, and each area are equipped with weather station. Those weather stations allow us to control multiple parameters at different heights. So at 1.5 meter, we control the air temperature, the humidity, and the globe temperature. At 4 meters, we also control the air temperature and the humidity, but also the wind speed and the solar irradiance. At 5 centimeters deep in the pavement, we also have a sensor that controls the temperature and the heat flux. So on your right, you have a picture of the weather station installed in Rue Frenicourt on the left. In the middle, you have Le Courbe, and on your right, Courcelles. To evaluate the impact of those innovative pavement and of the watering pavement, we identified a couple of indicators. So the principal are the life indicator, which are the air temperature and the UTCI. The UTCI is an indicator of heat stress. You have the scale on your right, and it's calculated from the air temperature, wind speed, relative humidity, and mean radiant temperature. We also identified additional indicators, which are heat flux and temperature at 5 centimeters deep in the pavement. So here now, this is the diagram of our 3 streets. So just as said earlier, each street are split in different areas. In blue, you have the innovative area where has been installed the innovative pavement. In H blue, you have the reference area where a classical pavement has been renovated. So both of those areas are watered during heat wave. And in orange, you have the control area where no renovation has been made. So we didn't touch the pavement. So it's a classical pavement. And this area remained dry during the watering campaign, because this is a comparison point. To trigger the watering campaign, we have weather station. Those criteria are loosened compared to heat wave alert in Paris. They must be reunited during 3 days before the watering day. And those criteria are on the maximum and minimum air temperature, on the wind speed, and we need a sunny day without cloud. So during all summer, we do a monitoring of the weather. On the top, on your right top, you have a picture of a watering campaign. So we have a truck to water the pavement, and a man will water the sidewalk. So this is a picture of the watering campaign of this year, located in the street of Courcelles. So you can have an idea of our data sampling. Here are a summer review of different summer. So for the watering campaign of 2019, we had from 10 to 12 watering days, depending on the street, and we have around 11 to 15 reference days. A reference day, it's a day with the same weather criteria of the watering day, but we don't we are not watering. So, for example, it can be a day from the weekend, because we're not watering during the campaign. For the summer 2020, we had 4 days of watering and 8 to 9 reference days. Finally, for the summer, for the watering campaign of 2021, we had 6 to 8 watering day and 7 to 8 reference day. So a typical watering day starts at 7 in the morning and finish at 11:30, and we have one watering each 1 hour and 30 minutes. So the afternoon, it starts at 2 and finish at 6:30, and we have one watering each 30 minutes. In reality, the frequency is more around 45 minutes because of the traffic. So we're going to start with the macroclimatic analysis that I will introduce you quickly. So in this analysis, we studied 3 impacts: the pavement impact, the pavement and plus watering. So for the 2 first, we only do this study for Rue de Courcelles because we need to have the characterization before renovation of the pavement, which we don't have for Rue Le Courbe and Rue Frénicourt. And the last impact is the impact of watering, which I'm going to talk today. So quickly, in this macroclimatic analysis, we studied the pre-existing differences between two areas. So, for example, between the pre-existing difference between the innovative and control area. So we're going to study this difference. We're going to start with a day, with a reference day, so with a day without watering. And then we're going to do the same study, but for watering days. And then at the end, we're going to study the evolution of this difference between a watering day and a reference day. And that's going to give us the watering impact. But because the microclimatic, microclimate, sorry, is very complex and influenced by a lot of things, such as, for example, a cloud located above our street, or a truck that's gonna park just behind our weather station. We have a really noisy signal. So to get rid of this noise and isolate the watering impact, we must do a statistical test. So at the end, we obtain a graphic like that. So here is the results for the Frémicourt, the innovative area of Frémicourt. On your left, you have the effect on the air temperature. On your right, the effect on UTCI effect. So for reminder, the UTCI is a stress heat indicator. And so in blue, you have the results of you have the average effect. So this is the result of the study of the evolution of the differences. In green, the green slope is a confidential interval. In red, this is the statistical significant event. So this is the moment that we can say this impact is from the watering. So those results show us three things. The first one is that we can see impact of watering during 24 hours. For remember, we are watering between 7 in the morning and 6:30 in the afternoon. And also we can see the max effect. So on the air temperature here, we can see a reduction up to 1 degree and up to 2.1 degrees for the UTCI. So this is a moment during the day, or it's just a moment. It's not representative of all the day. We also obtain the average effect, which is up to 0.4 degrees on the air temperature and up to 0.7 degrees on the UTCI. And this average is calculated on 24 hours. So here, a little overview of our results. So for the max effect, we obtain a reduction of the air temperature at 1.5 meter up to 0.6 degrees to 1 degree. For the UTCI, we add a maximum effect up to a reduction up to 1.6 degrees to 2.2 degrees. For the average effect, we obtain a reduction for the air temperature up to 0.3 degrees to 0.4 degrees, and for the UTCI, reduction up to 0.4 degrees to 0.7 degrees. Now we're going to talk about the thermal analysis. So in this thermal analysis, we study two things. We're going to study the heat flux at 5 centimeters deep in the pavement to obtain the drying time of our pavement. And we're going to study the temperature at 5 centimeters, where we're going to try to analyze the watering impact on the temperature of amplitude. So here are an example. So this is on your left, you have the innovative area of Le Courbe, and on your right, the reference area of Le Courbe. So those are the slope of the heat flux in the pavement. The blue slope are for the watering day, and the red one are for the dry day, so reference day. The first thing that we can see is that for the watering day, the slope is lower than for a reference day. Reference day. We also can see observed on the blue slope some peak. That's when the truck is watering the pavement. We'll observe that the heat flux is going to be reduced, and when the pavement is going to be dried, the heat flux is going to increase again. So that allows us to determine the drying time for a pavement. Now for the temperature. So again, on your left you have the innovative area. On your left. On your left, the innovative area, and on your right, the reference area. The blue slope are for the watering day, and the red one are for the reference day. And so here we can see, more easily on the reference area, that the temperature amplitude are lower when we are watering. So here, the temperature are normalized at 0 degrees, so we can see more clearly the difference between the amplitude. So to summarize the results on the thermal analysis, so we have visible effect of the watering. For Le Courbe, the mean amplitude was reduced up to 1 degree for the innovative pavement, and 3 degrees for the reference. And for Courcelles, the mean amplitude was reduced up to 4 degrees for the innovative pavement, and 2 degrees for the reference. For the drying time, we observe that innovative pavement dries 3 minutes slower than the reference one, which is for now not really significant. We don't have yet results for Semico because the captor has been undamaged, so it wasn't working for the summer 2019 and 2020. To finish and to complete in situ experiment, we have a lab experiment where we study the thermal behavior of different pavements. So on the left, you have a picture of the experimental device, and on your right, a diagram of the climate chamber. So we're going to control the air temperature and relative humidity. We have a lamp, halogen lamp that's gonna simulate the sun. The sample gonna be equipped at different depths with the instrument where we're gonna study the temperature and the heat flux, and we have a sprinkler so we can study the watering. The experiment is split in 2 parts. You have the day part of 8 hours, where the sample gonna start the heat, and the night part of 16 hours, where the sample gonna restitute its heat. And so we just started to study our 3 innovative pavements, so we don't have results yet. Thank you very much for your invitation, and if you have any questions.
Thank you. Yes, there are indeed some questions from Greg. You can read it also if you want. A question about the permeable pavement. Is the subbase also permeable, allowing water to drain to soil? Or it is only the top layer of asphalt permeable with the goal of water collecting in voids and then slowly evaporating?
So if I'm not wrong, it's the top layer that will be permeable, and so allow the water to be to stay a little bit longer. But we are also limited in terms or just the layer.
Thank you. And a follow-up: were you watering with trucks to explore how rain would affect the cooling, or were you actually considering using water to cool the streets as a city operation?
It's for now, so we are using truck, and it's not well in Paris. You have two network of water. You have the non-drinkable network. So that's why this study has been launched in Paris. And the idea is for the experiment, we are using truck to water, but that's not the big solution. The idea is to have another solution to water will be more easier. I'm not sure.
You mean like having some water utility lines that could actually like water the pavement from little outlets on the curb, something like that, with recycled water?
Yes, because today it's not possible to water the. It's just for the experiment and evaluate the impact if it's interesting or not to continue this solution. But using trucks like that is it's really complicated. So maybe in future, I don't know.
Thank you very much.
Thank you.
Thank you. Any other question? Let's see the chat. Nothing there.
Yes. Question: do you think water
Yeah.
is a sustainable method? Is water you use recycled? So normally we use the non-drinkable water. So it's a water that is not treated, and the water that we use is going back in the network. Sorry, I don't have the word in English. So yes, it's kind of recycled. It's not. It's interesting for Paris because we have this network. After this method is interesting depending on where it's located, and this solution we don't. The aim of this solution is not to water all Paris. The idea is to identify the zone that can be interesting to water. So, for example, where people, tourists are and are exposed at the heat. So it depends on where we are, which city, where. So, sorry.
Yeah, of course. Yeah, thank you very much. We must go on. I think this kind of solution is not possible for Murcia because they have quite a shortage of water. And for example, in Ljubljana, we don't have any secondary system for recycled water or non-drinkable water. Everything is drinkable, so cannot be implemented. But you know, research is important and valid probably for Paris and maybe some other places in Europe or somewhere else. More questions? If not, I would suggest to go on to LIFE HEVIA project. Arnaldo Melloni from Florence.
Yes, good morning and good evening. Good evening and good
Share
morning.
the screen and start the...
Yes, I share the screen. Can you confirm that you see my screen?
Yes, just use the presentation mode and that will be fine.
Okay.
Perfect. Yep.
So my name is Arnaldo Melloni and I work for the Florence Municipality Environment Department, and I'm the project manager of the project HEVIA. In this first slide, you can see some general information regarding the project. As you can see, we are more or less halfway through the project. With the other beneficiary associated are Continental, private company of tires, Ifstar from France, IPOL is a private company from Pisa, University of Reggio Calabria, and the Vienrose Ingegneria is a private company in Florence. In this slide, you can see which are the objectives and the scope of our project. So we start to take the noise pollution from road traffic noise, focusing on a future perspective in which electric and hybrid vehicles will be a consistent portion of flow. We work to optimize a solution for reducing noise in urban areas using road optimization in tire development. The third is optimizing road surfaces and tires of electric vehicle, and we use 2 road surfaces and 5 different electric vehicle to test and to find the right solution. And also we use a soundscape holistic approach to evaluate the performance of the vehicle in a new scenario. These are the expected impact, and in the area in which we are working, we think that we reach the 20,000 individuals involved in our project. This is our third LIFE project regarding noise, so we think that the number is a correct number using our experience in previous project. We estimate a reduction of noise in 5 dB, and we use a soundscape improvement, and we are interested to not only in a quantitative value, but also we are interested to understand the acoustics perception and comfort of an optimized asphalt and electric vehicle respect to the standard one. In our pilot area, the number of people affected by reduction noise are in 2,000, and the estimation is based on the evaluation of the number of the residents in a buffer of 50 meters from the street's axis. Other expected impacts, we will work, of course, for reduction of road traffic noise levels from the vehicles. And regarding the reduction of CPX noise levels at the 50 kilometers target or LCPX below 18.7 dBA should be achieved for the optimized prototype surfaces. We also expected a reduction of CO2 thanks to an increased use of electric cars in the mitigated area. We work in a specific actions to create the condition to promote electric mobility and raise awareness for noise and other environmental issues associated with the road traffic. I'll show you this slide just to show you the actions that we are doing. So we started with the preparatory actions. So we are now during the implementation actions, and we have also monitoring of the impact of the project actions during all the project, during the time of the project, also as the activity of public awareness and dissemination of results. We have also, as in all the LIFE project, a part of management and a plan, an afterlife plan. So this is the road, the pilot case road that we selected is an important road in Florence, and now I show you why we choose this road. It's a two-way travel without significant curves. Is a significant population density in this area. It's a busy road because it's an important road to the center, drive to the center of our city. It's close to public offices, for example, the Regional Agency for Environment Protection area, an office of our metropolitan area. Is close to the most relevant park in Florence, and also is close to one of the most important interventions of urban requalification. This is the steps for the procedures to construction the asphalt in this Via Paesiello, in this street. So in September 2020, we have the technical documents. We prepared in December 2020 the new mixture and published the tender in March 2021, and we receive we find the winner in June 2021, and we implementation we do the job during the summer. We now two slides with some technical solutions regarding tire and asphalt. The first one regarding tire, as you see, and the idea is using tires for electric vehicle, which are designed to give an optimal holistic relation between low exterior noise and other key performances. So we are talking about rolling resistance, safety, and wear. And the idea is that the sustainability of low noise tire is only given when a holistic performance is assured. And here some information regarding the road surfaces. We have a test area in Nantes, and at the end we have the final prototype that we use after in our cities, and you can see here the technical solution that we adopted with this asphalt. We try with or without crumb, and we choose at the end for a crumb rubber. To verify the noise reduction compared to a traditional asphalt, in the pilot case, we laid the two stretch of asphalt, one traditional and the low emission one developed as part of the project, so the other 150 meters. And the results in Nantes, in the test area in Nantes, was we find reduction levels of approximately 4 dB, and now we are waiting for the result of the pilot area in Florence. We have in the next month, I think we will have the result of the levels in Florence. So some picture of our job. As I said before, we are interested to understand the perception of the residents. So we had two surveys, one ante, one post operam, and a couple of days before the delivery of the questionnaires, we sent to all the citizens an informative letter regarding the project, the idea behind the project, and so on. This is the surveys. I think that it's impossible to read something here, but if you want, I can send you, of course, all the information that you want. And I'll show you now some results of the surveys. It's the number of the delivered questionnaires, ante operam and post operam. And here we have the result of ante operam analysis. So as you can see, we have the perception of the noise pollution is it's important. The quality of soundscapes in the area is not so good, as you can see, and most of the citizens involved in the questionnaires think that the implementation of intervention for reduction of noise could increase the value of the home, and they think that intensity of traffic noise in the soundscape around is very high, and they associated the traffic noise with the health, with the problem with the health, and the effect that by reduction of noise levels can be a solution for health problems. And these are preliminary post-operam analysis, because we are working on this data. We have not finished, but the first results says us that the people, the citizens, are very impressive, impressive by the intervention, as you can see. But if you are interested, we will have the finished result. I can share with you, of course. So we have some policy implication of our project. And the idea is contribute to national, Italian, regional policies with guidelines, and the idea is share the results of the project with our regional environment department agencies or that support our project in accord by Tuscany region. And also we have an interest by Calabria region and city of Reggio Calabria to contribute to share these guidelines, to use this guideline. Also, we'd like to contribute to EU legislations, effective implementation with the focus on the directives regarding these items. Continuation, so replication, transfer, market, uptake, and so on. Our idea is we'll continue maintaining and monitoring the effects of the optimized pavements in the 3 years after the project ends. And now we are working to use this new asphalt also in other three important streets, because we think that if we want to continue to create the condition to have a good results, we need to use these asphalts in every street as possible. So now we start in two of the most important streets in our cities. And we will use it also in our zero emissions zones in the city centers where only electric vehicles are admitted. And the idea, and this is the idea of all the LIFE's project, is that they must be easily replicable in other urban areas. So we are at disposal the other cities that are interested to replicate our experience. The guideline, as I said before, will be provided as a project output, and at the end, other outputs of the LIFE EVIA project will be a new emission model for electric cars. And of course, the idea is provided in order to evaluate our contribution within statistics mapping according to the EU directive, EC directive. And another output is the development of a new testing framework to design road surface for mixed fleets, with increasing participation of electric and hybrid vehicles. And we think that it's very important to promote and support electric and sustainable mobility. So every year we organize, this year we organized the first, and we want to proceed to organize an electric car festival in Florence to share with our citizens the results of our project and to promote and support electric and sustainable mobility. Conclusions. As you said before, the previous presentation said before, in Europe, the acoustic scenario in urban environments is mainly characterized by road traffic noise. So it's important that our project, our LIFE project, working to find a solution to these critical items. And we think that it's important that these solutions are accompanied by soundscape analysis activities, estimation of electric vehicle rolling noise coefficients for the local fleet in order to support implementation of Europe legislation, life cycle and life cycle cost analysis are also important in Europe now for all the projects to evaluate the track efficiency, sorry, from a comprehensive point of view. So here you can find the website of our project, where you can find also our contacts if you need more information regarding the project. And that's all. Thank you.
Thank you very much, Mr. Melloni. Of course, there will be questions. Let's check the chat. Nothing in chat. We are not a big group, so you can unmute yourself and just ask the question, no problem. Go ahead with them. I know people in United States are more open to making questions than in European culture, so that's a good opportunity to use that different cultural difference.
Yes, I'll ask a question.
Okay, go ahead.
Thank you for the presentation. Yeah, we've found using in Arizona on our highway system, we've used rubberized crumb rubber asphalt, partially for noise mitigation, and we've typically thought of it as a high speed an effect at high speeds, and not really at lower speeds. What are the speeds on this on the project, even if it's in kilometers per hour? And have you thought of do you see that at low speeds or at high speeds, the impact on noise?
Arnaldo, unmute yourself.
Sorry, in the pilot area, maximum speed is 50 kilometers per hour. We tested the asphalt in a test area with using a car with 18 kilometers per hour, and you are right. Best results are with high speed and not in low speed, but we find good results also in the pilot case. We are waiting for the last results, but the first measures show us that we obtain good results also in low speed, also with low speed. The problem is the maintenance, of course. We need to maintain the asphalt. So in 3-4 years, we need to create the condition to change again the asphalt
Okay, I have also one question. We know that the electric vehicles are more silent than the noise, so then reducing the rolling noise, it's then making the situation even worse. So how to deal with that problem? Because I have heard that they are, planning some artificial noise to be produced by electric cars, just to, in terms of assuring safety and people to know that these electric cars are moving and coming towards people.
If I understand your question, we had this problem, especially in the center of the city, where it's possible to use only electric vehicles. So we need to use some rings, some sound to advertise, to show the people that a vehicle is coming. But in a normal condition where our electric vehicle and the traditional vehicles, we have not this problem. We have the problem of the rolling, and so the target of our project is exactly to find a solution to this problem of rolling.
Of course. Any more question? If not, I have another one. You know, I think this is in terms of project consortium, it's very interesting consortium. You have, you know, organization dealing with electric cars, and then producer of tires and others. So, you know, this is cross-sectoral in our European terms project, which might really be a good approach to solve a, let's say, common issue. What can you tell us about your experience in collaboration with organizations from other, let's say, sector?
It's a very good and important experience. I think that have a partner as a Continental, for example, very important private company. It's very important. It's very as can I say, it's very enrichment for a public administration as we are. And I think that it's interesting to find the right combination between the different way of work, or different way of interaction. But we have found a good way to stay together, and I think that it's a great opportunity for us to work in this way, to work with a private company so important.
Okay, thank you. If there are no further questions, let's move over the Atlantic to the so-called Valley of the Sun, to Phoenix, Arizona. And this is not some invitation to go there as a tourist, but information that they had, I read, 5 months of the year to bear with 38 degrees Celsius on average daily temperature. So not very nice place to live. So Ryan, go ahead. How you doing?
Well, thank you. Oh, we we rely on our air conditioning, and you kind of get accustomed to it. So it's a very nice place to live, actually. You're all, of course, welcome to come, but I would suggest in the months of February, March, January. Those are the better times to come. It's not quite as hot. But good afternoon, everyone. Thank you for inviting us to present to you. I'm with the City of Phoenix. Joining me is Rubben Lawley. We'll be tag teaming the presentation on our Cool Pavement program. We'll be discussing what was our pilot program, but I'm happy to announce that last month we have moved out of the pilot phase. So we'll be doing more of this type of work, and Rubben and I are excited to share it with you all. So I will start sharing. All right, I think you're all seeing that. Yes. As I said, Rubben and I are here to speak about our Cool Pavement program. Very briefly, we'll be discussing a really quick few pieces of information about the City of Phoenix and our street network, and then we'll get on to the Cool Pavement program and be happy to answer any questions. So the city of Phoenix, again, it's actually quite a nice place, even if it's hot, is the 5th largest city in the United States. We're home to about 1.6 million residents, over 520 square miles. That puts us larger than the top 3 cities in the US in terms of their population. We're larger in land area, so we're a very spread out city. This is essentially what Phoenix looks like on a map, again, over 520 square miles. And just a little bit about our political structure. We have 8 council districts that each have a representative on the city council, plus the mayor. So there's 9 members of the city council, the mayor, and then 8 of the council members that represent specific districts. In terms of our street network, we have nearly 5,000 centerline miles of streets. They're divided up into our arterial network, which is our major arterial streets, usually in 1 mile segments. And then our local street network, that is, that takes everyone to their homes off of the collectors, typically grouped in a half-mile by half-mile grid. City of Phoenix, being so large, we have quite a few challenges. Of course, an aging network with limited budgets. These are common things that every municipality must face. So of course, we have our goals to maintain our network as best as possible for as long as possible, while remaining cost effective. And we're always look at improving the way we do things. So different maintenance treatments, including our cool pavement, and then any advancements in paving and maintenance technologies. So to talk about our cool pavement program, again, we'll be discussing the pilot project that took place last year. So first, the pilot program is a collaboration of the City of Phoenix Street Transportation Department, our Office of Sustainability, Arizona State University, which is nearby to Phoenix in Tempe, a suburb of Phoenix. They've been our research partners in doing a lot of data collection and analysis for us. The product and the manufacturer was a great partner in this pilot project, and of course our contractors. So this is work that's done right now by a private contractor on behalf of the city. Why is Phoenix looking to apply cool pavement? Well, of course, we're probably one of the hottest large cities in the United States, and we know what effect heat has on health. So we're looking at ways, again, in trying to be innovative, seeing if the pavement can be addressed. We know the paved surfaces in an urban setting can take up about 30 to 40% of the land area. So it can be a major contributor to the urban heat island. So that's why we're, looking to cool pavement technologies. And it's a pilot project because it is new for the city. So we want to tread carefully and prudently into new technologies. I want to thank Greg for kind of being on the bleeding edge of this kind of work, so that Phoenix can be then on the leading edge, just a little bit of a half step behind, and take some great lessons learned from the city of Los Angeles. And then what benefit do we expect? Well, of course, we expect to see some cooling, hopefully measurable cooling for our residents, but also that this is a pavement surface treatment that will improve our maintenance cycle and be a great tool in our pavement maintenance toolbox, as that's what my group does, is of course maintaining our streets. Really quickly, how this project came about: in October of 2019, the city of Phoenix participated in a workshop in the city of Los Angeles to look at what they were doing. In November, we then selected locations to be further vetted by the city council district offices to do the pilot program. In April of 2020, which is right at the start of the COVID-19 pandemic, the council district approved the locations. We then brought on our contractor and ASU for study, and we did our first installation. In June, we had our virtual public meeting. It was actually the first virtual public meeting that our department had undertaken in the pandemic. So after all public meetings had stopped, this was our first foray into the virtual format with WebEx. Then in August through November, we did the installation of the pilot program. This past September, we then published our year 1 study results from Arizona State University. And then in October of this year, we have done one additional location. So again, very briefly about the project. This is a map of the city of Phoenix, and our 8 council districts are highlighted there in the different colors. And we're showing here where all of the installations are. So they're throughout the city. Again, being so large, the city has a very different character depending on which council district you are in and what area of each council district you're in. Again, we did one in each council district, and then we also did a city park in the parking lot. In total, the pilot program covered about 36 miles or 58 kilometers of these residential and minor collector streets. As a seal coating product, the locations were for the pilot program based generally on the pavement condition. The road had to be in a good enough condition to receive the treatment, and then also the feedback from the council offices. And again, installation took place between August and November of 2020. So a little bit about the product we're using in the pilot program. It is an asphalt seal coat product. It's called Cool Seal, and the company is Guard Top. This is one of the products that was used in the city of Los Angeles that they had success with. So as an asphalt seal coat, it's an emulsion, asphalt and water, the emulsifiers, and it's heavily polymer modified. So it's generally safe and non-toxic. It's suitable for roadway activities. The main difference being that it, of course, instead of being black, it's lighter in color, with the goal of increasing the reflectivity of the road, the solar reflectivity. It can be applied with a spray or a squeegee, and that's actually something we're very proud of, is pushing our contractor and the manufacturer to have that spray methodology really dialed in so that we could put down a lot of product at once. As an asphalt seal coat, it is compatible with our existing asphalt surfaces. That's important for the city for when the pavement does come to the end of its life and we look to recycle the roadway in some way. And then, so that's a little video of how the spray truck works. It's going in slow motion right now. And then it is, as an asphalt seal coat, it is more durable than paint. So we want to make sure that's clear. We're not painting the roads. We're using an asphalt-based product. Of course, we started with the squeegee application in Esteban Park. The city park was the first installation we did. So I don't think this video is going to play, but you can see a little bit with a buggy, and it goes around using a squeegee application. But then we moved on to the spray application, and you saw a little bit of that in the previous slide, but this is what it looks like actually in a neighborhood. We're using a drone here to follow the truck as it's applying the second coat of the product. And it continues like that, so I'm going to cut it a little bit short. There were, of course, some challenges during our project. During construction, of course, we had residents driving through the material. That's a typical problem we have. So we mitigated it by having extra police officers to enforce closures and restrictions. We also added additional traffic control measures by putting some flagging in front of the driveways. And then after construction, one of our challenges, of course, is since it's lighter in color, you can see the tire marks more easily. So we are examining that effectiveness. How effective is it if it's getting dirty? We're also going to be looking at color in the future to maybe mitigate the aesthetic complaints we get for these tire marks. And with that, I'm going to pass it over to Rubben to talk about the ASU study and the results.
Oh, thank you, Ryan. Hello, my name is Rubben Lawley. I am Ryan's colleague here at Phoenix. My title is a Special Projects Administrator. Me and Ryan have been in this cool steel study and implementation program since the beginning, and we are proud of how far it's gone. Greg Spot, to me, when it comes to cool steel, is my mentor. His project inspired us to keep going, and this is where we are today. So as part of the cool seal, instead of just installing it and saying, okay, we've done it, we actually worked with Arizona State University to study the cool seal program. And they did a holistic assessment of the project, in the areas that we applied. And the main thing they did was that they did a detailed on-site full day assessment of the local microclimate in 3 neighborhoods on extreme heat days, and they used a vehicle traverse, which is out this, and something called MADI. It's a proprietary biometeorological, oh, that's a big word, mobile platform. This was completed between August and September 2020. Also, some of the specific questions they wanted to answer was, what are the differences in surface and air temperature, as well as the radiant temperature for the traditional asphalt concrete versus the cool steel pavement across the day in the same neighborhood on a hot day. What are the temperature differences in the top and the bottom layers of the asphalt concrete beneath an untreated and a cool seal or cool pavement treatment surface? Because we think that temperature differences will enhance the performance of the pavement over time. Also, how does solar reflectance of the cool seal change over time? So we did that study. And then what are the perception of the residents regarding the benefit and potential drawbacks of the cool seal? So we're going to present the results, and this is we did what is called a helicopter overflight of the areas where we implemented cool seal, and that gave us an infrared thermal image of what the cool seal looked like. So on the next slide, you would see the thermal image, and you see that the surface temperatures with the helicopter overflight show like 10 to 12 degrees Fahrenheit at noontime and after hours, 2.4 degrees Fahrenheit lower at sunrise, which is in the morning, it's still cooler, and then also 4.8 degrees Fahrenheit lower after sunset. So the cool seal literally reduced the surface temperature as we were hoping for with this measurement. The next image would show you, the side-by-side comparison. So as you can see, the blue areas are the cool areas, which has the cool seal applied, and the untreated areas are yellow or red. One interesting thing about this image is that if you look at the top of the buildings, they are really red. And in Phoenix, I think this is a revelation that rooftop treatment can help also mitigate heat, or at least reduce air condition, electricity usage in the home, because this tells us that as we cool the streets, which are darker, the roofs are even hotter. So that's something that needs to be looked at. Air temperatures. So overall, we determined that there was an average of 0.5 degrees Fahrenheit in air temperatures. The cool seal areas has lower temperatures, and it varied from 0.9 degrees Fahrenheit to 0.1 degrees Fahrenheit. So the daytime difference average about 0.3 degrees Fahrenheit, which is lower for the cool seal. But the thing is that for cool seal or for air temperature, it's a little tricky because, as we all know, there is mixing of air. So I don't know if what we measure was actually attributed to the cool seal itself. But for small neighborhoods, there will be mixing of air, there will be shading will vary, vegetation patterns will vary, people will water their lawns. So, we are looking at ways of actually measuring the air temperature difference for the cool seal itself. But this gives an indication that the cool seal, has a positive effect in reducing the air temperature. Mean radiant temperature, that is the mean radiant temperature is the human's total radiant heat exposure walking on the surface. So when we use the MADI for the cool seal pavement, had higher than the traditional asphalt concrete at noon, and after hours by about 5.5 degrees Fahrenheit. Due to the reflectivity, at sunrise and sunset, it was 0.5, which is approximately about 0.5 lower. So, the mean radiant temperature was lower when the weather was cooler, and then it was higher when the weather was hotter. So, but, these differences is similar to what we experience walking on a concrete road, over a concrete road or a concrete sidewalk. So we think that it's something that we already exist on the road. But the good thing is that we are applying it on the road that would have been otherwise hot. So this is a trade-off that is necessary to reduce the surface temperatures using the cool seal. Also, we did a temperature measurements at the surface and the subsurface. So, we realized that there's a 5 degrees or 5.1 degrees reduction in the top temperature in the cool seal compared to the control. And at the bottom of the cool seal pavement, there's a 4.6 degrees reduction in the bottom temperature compared to the control. So the temperature difference between the top and the bottom is on average 2.1 degrees Fahrenheit lower on the cool seal pavement. So the value of this is that, because of the lower thermal gradient in the cool seal, this would help reduce or mitigate how quick cracks form in the pavement and help improve the pavement life. Also, we did some preliminary assessment of the performance of the cool seal. We realized that the cool seal has a higher heat capacity when compared, specific heat capacity when compared to asphalt concrete. It is significantly less conductive than conventional asphalt. And we did a bond test and realized that the bond test between cool seal and the roadway was about 35 degrees PSI. Sorry, we used all these American units, but hopefully it makes some sense to you in terms of relative value. And then we, compared to asphalt. But the thing is that asphalt, liquid asphalt is different. We are going to look at, we have slurry seals and we have, other treatments that we put on top of the roadway. So it will be interesting to know the bond strength difference because we think that cool seal is comparable to those treatments. Surface reflectivity. So the reflectance varied between 33 and 38 degrees percent reflectivity when it was installed. But then the reflectivity, as usual, declined over time, and it ranged from 19 to 30 degrees across the 8 neighborhoods. after 10 months. But you know, asphalt has a reflectivity of 12%. And also one thing that we noticed is that, you know, luckily for the valley, it rained a lot. We call it monsoon season. So, you know, most of the area, this was done just before the rains, but after it rained, we saw that the cool seal was a lot cleaner, but we haven't gone back to study it yet. But we think that the reflectivity goes back up after it rains. And then also we talked to our neighborhoods. You know, we did a survey. And these are some of the results that we got. So some were satisfied with the communication from the city. You know, this was implemented, you know, on the time that we wanted to get it done in the summer. So, you know, but some of our neighborhoods or our residents thought that we could give them more information about the cool seal, but most of them were satisfied with it, and they were interested to learn more about the program. Some also, you know, expressed concern with the visual appeal because the cool seal is lighter and it gets relatively dirty after cars drive on it. But like I said, the product is, they say, is hydrophilic and it's able to clean itself, self-clean after it rains. People are also worried about the impacts to their property values. Some think it would, some think it wouldn't. Also, the longevity of the coating and then also surface friction. We attempted to measure surface friction, and some of the results we got indicate that the cool seal does not really affect surface friction because literally we currently install it in the local streets where, you know, speeds are very low. So friction, we don't think would be an issue, but we will continue to study it as we continue to install more cool seal. Collectively, the interview and preliminary survey results point to opportunities for additional resident engagement and education concerning the cool seal program. Here are some, on visual appeal and aesthetics, here are some negative or positive, let's start with the positive, a comment. And it says, if the pavement lasts, it will bring value to the neighborhood. And that's true. It makes the neighborhood look nicer and thinks that it is a point of interest for home buyers. People have not said much in the way of negative comments. The effect or the glaring effect is not as big as an issue. Glare, we think it's a perception thing because you still get glare on dark asphalt. So, and that's what the project team thinks about that. And some of the negative comments are that at first, you know, it was very glaring. It had a lot of tire marks, but the glaring effect has toned down. I think this is a positive. Some said that they've tried to avoid the street that have the pavement because it is blinding. People also talk about the tire tracks and oil tend to show up more, and the tire marks and oil stains. Some of these we are trying to mitigate because just as we challenge the supplier to, you know, improve the application process, we also challenge them to think about how they can modify the color. And we are in the process of implementing a second, you know, mini pilot, even though we have full implementation, that installed a relatively darker or grayer product. And even that product, though it's darker, had higher reflectivity. So it's very encouraging. So the summary, you know, a holistic assessment of numerous physical and social indicators of pavement at various time scales provides critical insight for the future, for future work, as well as useful information for the city of Phoenix and cities globally, you know, with similar goals. You know, this particular aspect of the report was put together by ASU, and of course, they see opportunity for long-term performance testing, additional resident engagement and education, a high-end air temperature testing, which we are going to engage in going forward, and then new types and new colors of cool seal product. So we are already implementing that. Actually, we are implementing a product called ARA Plus, which also touts to consume NOx and VOx. So some of the optimal locations that we want to put cool seal per ASU study says, you know, open lots which are not shaded, of course, because if you have shade, cool seal will not be an issue. But definitely, our thought is that if you plant trees, the trees take about 5 years to grow. So if you have heat in an area and you need to mitigate it immediately, cool seal will be the best option. And then when you get the shade, you have the double effect. Also in low-rise residential areas. ASU thinks that, you know, cool seal will not be suitable for playgrounds because in the afternoon, the radiant heat might affect children. But in Arizona, we typically don't play outside in the day's time anyways. So not in places where people spend a lot of time during the day, which, you know, in Arizona, when it's hot during the day, people are inside. It is people in areas that is already shaded because they don't think will maximize the value, and also in high-rise areas where the reflected heat might not be able to escape. But overall, we think for our local streets where residents live, this has been would be very positive for us. With that, we will open it up for questions.
Okay, Rubben, thank you. And Ryan, here are 2 questions in chat. Let me go through the first one. How did you evaluate the impact on the air temperature? Do you have a statistical study? That's the question.
So it's Arizona State University conducted that study, and they did the analysis for us. They compared the air temperature on a cool seal area to that of an untreated neighborhood. And then they used the device called MADI, which measures the temperature. And, you know, they didn't comment of significance because they didn't do a significant study on the air temperature. They just commented on the value of the air temperature because we think that, you know, like I said in the presentation, the measure that what we measured is a combination of the air present, the air mixing, vegetation. So for us to do a complete study of the impact of cool seal, we need to be able to, you know, eliminate all that before we can say cool seal by itself has a statistical significance.
Okay, so if I well understood, it's a difference between the control area and the pilot site. That's right.
Yes, I think, you know, some of the things that we talked about was, you know, if we had time, we would have done, you know, hopefully getting the same temperature of the day, do a before and after of the neighborhood that we treated. That would have given us an idea about what it is. But even that, you can't even predict the air temperature or the air, you know, velocity or mixing at that day. But we're not able to do a before and after of the same location with a repeated microclimate. So I think that is a challenge, but we will keep working on being able to get something like that going forward.
Okay, thank you. And last question, you use Marty, it's a mobile weather station?
Yes, right, if you can show the picture again. So ASU has a proprietary, they have 2 things. They have a vehicle that they've mounted temperatures on, thermometers on, thermocouples at the pavement level and above it. And they also have an equipment called MADI. It measures mean radiant temperature. So these are the 2.
Okay.
Yes, that's what they use.
Okay, and that's pyranometers below on the bottom. Oh, not the bottom. to control the radiation?
Well, if you can ask that question again, I did not get it well.
It's the instrument just behind, just on the bottom of, before the air temperature. It's pyranometers to control the solar radiation.
If I get you right, you said that, is it a number 2, the second one?
Well, yes, on the number 2.
Yes, yeah.
So
it's
you
called,
have air temperature radiation.
Yes.
And
Yes,
how
mean
do you
radiance.
you have a globe temperature to evaluate the mean radiant temperature? Or you
Yes.
calculate from the radiation and the air temperature?
So I think Arizona State University conducted this study, and the MADI has instrument in there that measure radiation in a certain frequency range. I don't know if I can provide much details on that, but I can get you in touch with the researchers to see if they can get you more information on that.
Okay, thank you.
I can chime in and answer too. I believe that the idea behind MARDI is to get a better directional understanding of the radiation. That's why those little discs are pointed in different directions. A typical globe temperature wouldn't tell you where anything is coming from.
Okay. Okay, I get that. And okay. And for the it's with the spectrometer that you evaluate the albedo. And what device is it? It's again a pyranometer that you use. Or...
For the long-term spectrometer study for the radiant, I think that
yes. Sorry.
For the number 5.
Yes.
Yes, so they have a specialty equipment. For us, the city, we have a thermal a thermal radiant temperature gun that we use to measure, but ASU have a special equipment that's able to measure that reflectivity.
Okay. Yeah. I'm asking that because we're using another device to evaluate the albedo. Thank you very much.
Oh, okay. So if you're able to, if you know, I can get you in touch with our researcher so they can give you more details on the device they're using. Maybe you share ideas and come up with something even better.
Yes, I will be interested. Thank you very much.
Thank you. Rubben, there is another short question. What's the price per square meter of the coal seal? This is top, and well, do you have plans to use it in the whole city as a standard solution? I think that was the question from Francisco.
I can give a comment on the price, and Ryan will give a comment on the standard. Okay. So regarding price, we determined that, you know, even it's relative, because we have a product called PMM, polymer modified master seal, which has about so the cost difference between the polymer modified master seal, which has even lesser body, it's about, I think, 13% or 80 cents less than the cool seal. So, which is relatively, for us, in terms of the value that cool seal provide, is definitely a lot more than that in terms of cooling, sustainability benefits, and then also pavement performance, long-term pavement performance. So yeah, we always talk about cost, but we want to evaluate in terms of value. So the value is there for the cost that we paid for.
And then yeah, for further implementation, you know, our city management and department management, you know, have been very excited and supportive of the project. So we have graduated out of the piloting phase. So we do anticipate to continue applying at a similar scale annually. So again, about one neighborhood in each council district per year. In terms of implement for the whole city, of course, the pavement condition has to be right. And we are also utilizing some information about shade needs. So there are areas of the city that are actually quite well shaded. So they may still get a cool pavement technology in the future, but we're going to try to prioritize those that actually are in a higher shade need first. So, but it would be applicable citywide in local streets, but we would prioritize, you know, higher shade need areas before lower shade need areas.
And I wouldn't mind if Greg chimes in, because as we said, we learned a lot from him, and he's also evolving his. So
yeah, he's next in the row. We are a little bit behind the schedule, but I would remind you on your thermo shots about the roofs. You know, that's some area where some work needs to be done to improve the situation. And actually, that was the reason for hotspot, the heat island in Ljubljana. Actually, that was the shopping area with some old shopping buildings with metal roofs, large surface and streets, parking places between. Actually, no much green area at past. Now they changed it. They planted quite some trees. And that was the hotspot in not the city center as such only, but also this shopping mall with these roofs, which was the reason for overheating of the area. So I think we are a little bit behind the schedule. Greg, can you help us with that a little bit?
Yes, I can.
I think Fran actually is waiting all the time for your presentation. And as I learn now, I think you are behind many things here in this island situation, story or research. So please.
Thank you. This has been a great webinar. I've learned so much. I'd love to see this group come together regularly. There may be a small number of folks on here, but these are the practitioners at the cutting edge, and it's very wonderful to share with each of you. I'm going to try to make this short, but information rich, and respond to some of the very interesting concepts and questions that have come up today. This has really been a great couple hours for me. So here in LA, you know, we started this journey in 2013. LA has led on some cool roof incentives, which then became cool roof requirements. We have about 50 million square feet of cool roofs installed in Los Angeles. By the way, we have 4 million people in Los Angeles and about 500 square miles. We have 69,000 city blocks of roads. So we had been leading on cool roofs, and the same environmentalists who were promoting that were interested in us getting into cool pavements. And in 2014, as we started these discussions with Climate Resolve and one of the United States national labs called Berkeley Labs, which has a heat island group, we found a report from another city in California that said, nowhere in California had a cool pavement been installed on a public street. This was in 2014. And we decided we wanted to be the first city in California to install a cool pavement on a public street. That was our initial goal. Why? Why does this matter? Well, a really interesting thing about this webinar has been the different evaluation methods that each city is using. Every one of them is interesting and has merit. And I'm learning a lot from all of you on the different ways you can evaluate this. One way LA's been looking at it is from space. we've partnered with NASA. NASA has a part called the Jet Propulsion Laboratory. They do the Mars rover. They build that rover right in LA area in Pasadena, a next door city to Los Angeles. And we've developed a partnership where we're looking at our city and our urban cooling projects from a thermal camera on the International Space Station. This thermal camera is called the EcoStress camera. And this data is available. You can pull EcoStress images yourself and post-process them. We're lucky to be working with a researcher who does that for us, but this data is available to folks on a self-serve basis if you learn how to do it. So this is my region, Los Angeles, on a hot summer night in 2018. Notice that you can see our roads, our freeways. This is one of our freeways here, our port, our airports, and there's no base map here. This is just a thermal image. Our entire road system lights up on these images because it's emitting heat. This one on the left is almost at midnight, but this one on the right is at 4 a.m. At 4 a.m., our asphalt and concrete roadways are emitting heat still at 4 a.m. in the morning. And this is very important because the human being has thermal recharge at night. The human being needs to cool down and sleep at night to be ready for the next hot day. And our roads are warming our neighborhoods exactly when people need to rest and prepare for tomorrow's heat. LA is going to get hotter. This area here, our northern rim in the San Fernando Valley, is extremely hot. How about this community here, Sylmar? Today, we have 54 days above 95 degrees Fahrenheit peak temperature. That's going to become 96 days. Porter Ranch next door already has 55 days. That's going to become 100 days. Can you imagine 100 hot days a year? Rubben, I know you can in Phoenix, but for most of us, it's pretty hard to believe. And then new neighborhoods will emerge as problematic. Places like Eagle Rock and El Sereno, which only have 13 very warm days a year, are going to have 40 days sometime between 2041 and 2060. Los Angeles is one of the only cities in the world that has heat-related emergency room visits and deaths in the winter. We can have a warm spell in January. People aren't prepared. We can have a humid, still air mass settle over the city, and people can end up in the hospital from heat. We've all discussed this. There's cool roofs, there's cool surfaces, shade trees and shade structures. And a wonderful thing about my agency is we also oversee and maintain 700,000 street trees along the sidewalk. And we've more and more been linking together planting shade trees with cool pavement solutions. And we also control the transit bus stops. We can put shaded bus stop shelters at our bus stops. And so really our agency is well positioned to respond to urban heat, being able to do shade structures, cool pavement, and shade trees. Our very first test was in 2015. We tried cool pavement coating in an off-street parking lot. And, we looked at coatings because we were worried that it would be very expensive to create cool asphalt. And once you ran a different asphalt formula in the plant, all that stuff is so sticky inside that you'd never be able to go back to making regular black asphalt. So I'm very, very excited to see the progress in Europe of actually making light colored asphalt. And I want to learn more about that. I'd love to be in touch with you guys because we'd love to learn about that. We have been worried that it'd be very hard to find a partner who would be willing to invest in that here in California. So we started with coatings. We found out that this guard top coating that Phoenix then started using was making the surface temperature of the asphalt 5 to 6 degrees centigrade cooler than adjacent. We liked this test area because we had this little median in the middle to make sure there was no heat transfer going back and forth. 2 years later, we installed the guard top product On one street in each of our 15 council districts, we were installing it by hand, 2 coats with people using squeegees. Then in 2019, we started doing neighborhood urban cooling projects. And our first one was in a San Fernando Valley neighborhood called Winnetka. We chose this street, Stephanie Drive, which is a crescent-shaped street, and it has 5 cul-de-sacs coming off it. And we also planted about 80 shade trees in vacant locations along the street. Well, when we visualized that from the thermal camera on the International Space Station, you can see Stephanie Drive from space. Look at this. This is this. And I call this the $4 million slide because we used this slide to obtain $4 million of funding from the policymakers so we could really take urban cooling to scale. Expressed another way, this data shows that the pixels seen by the thermal camera that were within 100 meters of the cool pavement were on average 2 degrees Fahrenheit cooler than the rest of the neighborhood. So this green line is the distribution of temperatures of the pixels near the cool pavement, and this red is all the other pixels in the neighborhood. And what I like about this method is we're actually studying all the surface area of the neighborhood, not just the roadway, right? And this would be very hard to do in person. Imagine trying to put sensors or go on property of people's private homes. You can't really do that. Here we can look at the whole neighborhood, not just the pavement, and see a temperature, a surface temperature shift at 4 p.m. and at 9 p.m. as a result of the cool pavement intervention. We used that information to develop a large project. It's still not as large as what Rubben's doing, which I find very frustrating as a friend and friendly competitor. But we decided to do 200 city blocks of cool pavement across 8 underserved neighborhoods and planting 1,900 shade trees, including creating 600 new tree planting opportunities by cutting new concrete holes in the concrete sidewalk where trees previously did not exist. We rarely have the money to do that. Most of our tree planting in Los Angeles is in available planting locations rather than creating new locations. We use some very interesting GIS-based mapping tools to identify the best areas for these interventions. We used the Climate Smart Cities tool for Los Angeles, which allows you to layer heat exposure and equity. We used the Google Earth LA City tree canopy map, which you can look at where is there an absence of tree canopy and how to correlate that with neighborhoods that already have a large number of environmental stressors. We have a map called California EnviroScreen that identifies neighborhoods that traditionally have been mistreated with environmental stressors, and we're trying to focus our interventions in those type of neighborhoods. So we brought this map. I have to say, actually, by the way, regarding my friends in Phoenix, when they did their big project in like the summer of 2020, I went to my boss, our director at the time, and I said, well, they've gone bigger than us. Now we're number 2. What do you want to do? And he said, come up with something so big and bold that the policymakers can't say no. And that was really exciting because last year at this time, the city budget was in a total mess because of COVID. Every dollar was locked up. And the idea of proposing something new seemed very crazy at that time. But in the winter and spring, we brought forward this 200 city plan developed by data, and we were able to get $4 million of funding to do 4 million square feet of cool pavement coating and plant these 1,900 shade trees with about $2 million of tree planting funding. We're currently, for this project, trying a different coating. This is the GAF Street Bond DuraShield. It is a sand and acrylic. It's sand with an acrylic binder and a water base. So it's not an asphalt-based emulsion. Because the binder is clear, you can make this any color you want. And this is a custom color they developed for us called Solar Gray, We're trying to make it a little darker, but still have a solar reflectance close to 40, 35 to 38. We're trying to see if perhaps if it's darker, but still solar reflective, we'd show less staining and tire tracking and see less degradation, less reduction in the thermal performance over time due to staining. And then over here on the right, you can see that one of these new tree wells, this is a school here that had no shade, and we planted 17 new trees in places that were previously just concrete. By the way, our purchasing power enabled our contractor to build a spray rig like this. I know Phoenix is using a spray rig as well. You know, this original method of, you know, applying with squeegees is too much labor, costs too much. We can drive these costs down a lot by automating it. And it's exciting that, you know, Phoenix and LA are using our purchasing power to drive down the installed cost of these products. A couple of takeaways from today that I just wanted to share. Number one, this concept of, you know, could we make light colored asphalt versus coating traditional asphalt? There's probably applications for both. I'm really interested in learning more about producing light colored asphalt. I think we all have a lot to teach each other about these different evaluation methods. It does seem like common sense that a black road surface is going to make the city warmer, but it takes a lot of effort to try to quantify what the benefits are to residents from these type of interventions. I'd like to encourage everybody to always think about trees. When you're thinking cooling and smart surfaces, think about tree planting as well. Trees are, we know that shade trees are a proven solution to urban heat. Let's add that whenever we're doing this more emerging experimental treatment of urban cooling. I'd also like to mention Phoenix and LA are sort of the founding members of the Global Cool Cities Alliance Cool Roadways Partnership. We have 25 North American cities in that partnership. It would be wonderful to have the European cities join that partnership. We meet by Zoom and share our case studies 4 times a year, and we interact with the industry together. It's a very, very helpful forum. Lastly, I want to invite each of you to come to Los Angeles. I want to take you out and show you our projects and show you an installation if that's happening at a time when you're coming. And then I hope I can invite myself to come visit you. I really want to see all the things that were presented on about continental Europe. I want to see Paris. I want to see the projects in Spain. I want to see the plant that's making the asphalt. I want to go back to Florence, one of my favorite cities, and see the quiet asphalt there. I love the idea of optimizing asphalt for the EVs and applying it in new zero emission zones. That's very clever and interesting. I think that's super cool. So how was that for being quick but meaty?
Yes, that was a nice conclusion of this event. I think I don't need to say much more. I would just say invite Francisco to actually, as a project coordinator, say a few words at the end. Let's see, there are some questions to maybe a couple of minutes. What you say, you are testing darker code, but with some reflectivity. Do you speak about code that reflect the infrared, in the infrared? How does the code ages, durability?
Right. You know, both GuardTop and GAF are offering a 5-year warranty, and we think that's very good. That's how long we expect coatings to last. Both of these coatings have maintenance benefits. You know, lots of road maintenance organizations use coatings to prevent oxidation of the binder where the sun breaks down the binder. to prevent water infiltration, water damage, to keep the fine materials, the sand, intact rather than breaking off. And it's very exciting to notice that some of the research that's been done in Arizona suggests that the binder of the asphalt below the coating stays stronger longer when the asphalt heats to a lower degree every day. When that peak heat of the asphalt is lowered, the breakdown of the binder is slowed. So it could be that cool coatings have more maintenance benefits by keeping the street cool. Yes, we're trying to work with these manufacturers where are there ways to maintain the reflectivity high while the color you can perceive with your eye is less light? Because there are multiple ways to drive the reflectivity beyond just color. And we're trying to work on finding some wonderful balance where the community likes the look, where it doesn't show a lot of tire traffic, where it maintains the reflectivity over years. And so we're working on that. Oh, I see they're waiting for me in Florence. That's awesome. You know, there's a 11 euro truffle pasta dish I had last time I was in Florence. And we kept going back to the same osteria every day because we couldn't believe something so delicious was 11 euros. I need to go back there again.
Okay, I think you will find also good dishes in Murcia. So to conclude this, please, Francisco, let's say a few words for the very end of today's workshop.
Okay, thank you. Of course, it would be great keeping in touch with you, Greg, and also all the other speakers, Arnaldo, Giulia, Mailys, Ryan, Rubben, all of you. It would be great keeping in touch and learning every day more about our technologies. And also thank you all for coming here, virtually coming. Okay, the technology makes it possible. And of course, as all of you have said, Greg, you have been our inspiration for all the people here today. So thank you for your previous work and the work you are doing. And of course, we cannot forget vegetation. We need to implement nature-based solutions in our cities because vegetation was first and we came later to the world. But human, we multiplicate ourselves so fast. Okay, so thank you for coming and see you soon.
Thank you, and good night to European partners, and good day or nice working day for American ones. See you next.
Thank you very much.
Thank you.
Okay.
Thank you.
Bye-bye.
Thank you. Bye.
Thank you very much.
Bye.
Bye.
Bye.